Today, we're going to clear out the cobwebs a little bit. We're going to talk about experimental probability. Why should you like today? Because you already know that probability, the first thing you should write down is favorable over total. And I'm sorry, that looks so wicked. So in this one, if you wake up before the sun is out, that's majority of us, okay? You have 7 green socks because you don't waste your time folding socks. You got 7 green socks, 10 black socks, 10 pink socks, 21 white socks, and 8 basketball socks. If you reach into your drawer in the early morning, in the dark, what's the probability you grab a green sock? Well, right here, the first thing you have to do is figure out how many green. 7.
Wait, are basketball socks?
And then you figure out, you add them all up and you get what?
54.
54. And just to make sure, does 7 go on 54? No, so you know you're done.
Wait.
Always reduce your fractions. Now, here's my question for you. Just so we all are on the same page. If I have a coin, on your whiteboards, tell me the probability of flipping the heads. Tell me the probability. If I have a coin.
Boy, I spilled. What the heck?
Good.
There's taco meat on my shirt.
What is the probability I flip, what did I say, heads? Good. And hopefully everyone thinks that it is 1/2, right? Yep. 1 out of 2. Now, the reason why we have to talk about experimental probability, right here I have a number cube. Number dice, okay? What is the probability that I get a 3? You can say it out loud.
1/6.
1/6. But hey, does that mean when I roll this 6 times, I'm going to get it at least once?
No.
Is there a good chance?
Yeah.
Okay, so what you need to know, and you already know from science fair and stuff, is what you expect to happen
Hypothesis.
doesn't always happen, does it?
Probability.
So that's why we call it experimental probability. So say this. Say I roll, well, I'll actually do it. Okay, so I got a 6 the first time.
Absolute garbage.
What?
6. Oh boy. If I get another 6, you guys are definitely going to know that this is from the
Are you okay?
2. What am I going to get next?
6.
4.
Oh, it's a
4.
I'm a beast.
What am I going to get next?
3,
A 1.
2.
Ah!
A 6.
Today's even day.
Oh my god.
Thank you. I comes up there. Thank you. And hopefully you'd say, well, this is fine. You only rolled 4 1, so it's going to be 1 out of 6. Tell me on your whiteboards, what is the probability I roll a 3? The experimental probability that I roll a 3.
0.
Yeah, say it louder.
0.
0. Didn't happen. So I hope you would tell me 0. What about, what's the experimental probability I roll a 6? Thank you. Thank you. Actually means that what is the probability that it should happen? Theoretically, what's the probability that I should have rolled a 6? Theoretically. 1/6. Because in a perfect world, I would roll a 1. I'd probably even roll them in order in perfect world, right? I would get a 1, and then I'd get a 2, and then I'd get a 3, and a 4, and a 5, and a 6. But that it actually happened. Theoretical probability is what should happen. Does that make sense to everyone? All right, let's get into the next one then. A softball player has 21 hits and 60 at bats.
That's bad.
It's not slow pitch. That's not bad.
That's not bad at all.
No, it's not.
That's
Not for fast
Like
pitchers. Express the probability the player will get a hit in her next at bat as a decimal number with 3 decimal places.
Why can't it be a he?
Because
Fast pitch is a female sport.
Why can't males
So here's my question, you guys. Probability is favorable over total. What's favorable in this case?
60.
21. Favorable means she got a hit. What's the total? What are you doing with these two numbers? Dividing. Thank you. Do that on your whiteboards. Show me that you can divide this number by this number. And but with 3 decimal places. With 3 decimal places. The bottom number you didn't divide by the same number as you did the top.
Yeah.
Otherwise, I would agree. And then 3 decimal places.
Anna, to yourself.
Can you start dividing? Start.
Divide.
Put the top number in the box, divide by the total. Put the top number in the box, divide by the total.
Top number?
Always goes in the box.
I don't like that.
Hey, watch your language on
Oh.
Christian Minecraft.
Yeah, my Christian Minecraft.
I actually don't know.
It's 3.8.
I think so. I don't think so.
Yo.
No, Boston.
Decimal's not in the right spot. Sir, you gotta pay attention.
I know what it is. Just wait. Calm down, bro. I got it.
I got it.
Call my mom that too.
Yeah.
She gets annoyed.
Okay, 60 goes into 210 3 times. You get 180. You get a. How many times does 60 go into 300?
I got it.
5. Exactly though, right? So then to 3 decimal places, where does that decimal belong?
Wait, it's not enough.
Here. What do we put after this?
0.
A 0. And last time I checked, okay, as a baseball player or as a fast pitch player, that's
not
actually good.
Yeah, it's not bad at all.
You want to be over 300.
It's kind of
Okay.
hard.
That is.
It is hard, yeah.
That's why
Okay.
it's so hard.
It's even harder to solve that problem if you don't understand what you're doing. So let's see if we can understand what's going on here. Salesperson. Oh, yes.
Service and Tim.
Salesperson, please listen. Distributed free samples at the mall. 50, you guys, please listen. 50 shoppers accepted the samples and 30 did not. What's the probability the shopper at the mall will accept the salesperson's samples? I'm going to read it again, but I want you to write and label what the numbers represent. 50 shoppers accepted the samples, 30 did not. What's the probability that a shopper at the mall will accept the salesperson's samples? 50 shoppers accepted the samples, 30 did not.
Are you kidding?
Ah, crap.
Thank you. Reduce it. Good. You writing any of this down?
Yeah.
Good. Now you make sure he's got it. Hey, this is what I'm looking for. Because hey, if you don't write down what it's representing, what did 50 shoppers represent?
The ones who took it.
Accepted it.
So they accepted it. They said yes to it, right? What did 30 say?
No.
No thanks. Okay? What's the probability that the shopper will accept? As soon as it says probability, you know that you have to think what over what? Favorable over total. What did some of you not
Be
do?
over 80.
Total.
You didn't add them together.
And the favorable is those who accept it. How many accepted it?
50.
5.
And then all you have to do is cross out your zeros, divide the top and the bottom by 10. Now, once again, do we need to know what the numbers stand for?
Yeah.
Yes.
Yes, you can all tell me that probability is favorable over total. But gentleman in the back is falling asleep on me. Yeah, okay, you who have a game today, you gotta pay attention to what the numbers stand for. Okay? So, last one, I told you we only have 3. So give me your best for one more. A commuter plane flight arrives on schedule 2/3 of the time. If you can't tell that this spinner, it says not on schedule, on schedule, on schedule. Raise your hand if you've been on a plane and it's been on schedule before. Okay?
Never been on a plane.
Raise your hand. I know, hey, I'm sorry. Raise your hand if you've ever been on a plane that's not on schedule before. Okay, yeah.
I went on 6
So-
planes and they were all on schedule.
Okay, it's pretty good. Now it says this.
I never want to go on a plane because
You guys.
I don't want to die.
So it said,
That doesn't happen to see it.
It's like scary to think of though.
okay, thanks. We're getting this all down. So Heather wonders what the probability is that it will arrive on schedule on Tuesday, Wednesday, and Thursday in the same week. How could the experimental probability be found, and why is this impractical? So, if this was actually your study, and you wanted to know of this commuter planes, is it going to arrive on time on Tuesday, Wednesday, and Thursday? Why is that not practical to be able to do that?
Because the number of flights change.
Okay, number of flights change. What else?
Where they're going, whether.
Scheduled.
Yeah.
Yeah, what about those days? Like, what do those 3 days have anything to do with it, right? How much time is that going to take you a while to figure out?
Yeah.
You're going to lose that in a hurry. Stop. So yeah, it's pretty impractical because, A, it takes a lot of time. But then what happens if she did it on all commuter planes? Would she be able to do that across the world?
No.
No.
It's way too much information, right?
Unless she's part of the Russian government.
Okay, so it's way too much information. So that would make it impractical. Then here's the question that it wants you to answer, and I want you to think about this. Be ready for me to call on you.
Why?
How could the spinner at the right be used to simulate the experiment? So of the Tuesday, Wednesday, and Thursday, how could Heather use this spinner that says not on schedule, and on schedule to say whether the plane's going to be on time or not?
I know whether Heather would know.
How could she use that
Pick
spinner?
a random plane, spin it. Oh, be on schedule. See if she was right.
So you're just kind of guessing and checking almost, right? Is that a valid attempt of doing math?
No.
No, it doesn't always get you, but does it sometimes help you? Yeah, it sometimes helps. Sometimes helps. Okay? Yes.
I searched up. Actually getting in a car accident or traffic accident is more
It's
probable
not
than
relevant.
actually crashing into a plane and
You're not relevant.
surviving it.
No.
So there's the fun fact of the day. Now,
People.
if you're wondering, so today, lesson 59, this is what I want you to do for tomorrow. Please listen. I want you to do A and B and C. So please write this down, lesson 59, because you do have 2 minutes that you could do A, B, and C.
Wow.
Okay, and I'm gonna check out how many start, and then I'll say even, I'm gonna give you 6 start. So you only have 9 problems tonight. So write down lesson 59 in your notebooks. A, B, and C, and the first 6 start. So how many problems? 9. Doable.
Land.
Doable. So thank you.
I have a nickname now. Apparently, I'm teacher because I kept telling